The interpretation of the connecting point of a kitchen peninsula can differ based on the jurisdiction and the specific inspector. However, two common interpretations exist. Firstly, the connecting point can be at the wall. In this case, the peninsula is considered to start at the wall where it attaches to the kitchen cabinetry. The countertop ends at the edge of the peninsula, creating a gap. This interpretation necessitates the receptacle on the wall behind the peninsula. Secondly, the connecting point can be at the countertop. Here, the peninsula begins where it meets the countertop, and the countertop continues over the peninsula, creating a seamless surface. This permits the receptacle to be mounted on the end of the peninsula or in the backsplash. It is crucial to note that the specific definition of the connecting point may vary based on local building codes and inspection practices. Consulting with the local authority having jurisdiction, or OJ, is always advisable to determine their interpretation before installing kitchen peninsulas. Consider the example of jurisdiction A, where the connecting point is defined as the wall. Thus, the receptacle must be installed on the wall behind the peninsula. Conversely, in jurisdiction B, the connecting point is defined as the countertop, allowing the receptacle to be installed on the end of the peninsula or in the backsplash. Given that the most common interpretation in one's area may be that the connecting point is at the countertop, one must not assume this holds true in all jurisdictions. The National Electrical Code, or NEC, addresses requirements for receptacle placement in dwelling units, including kitchen countertops and peninsulas. Although it does not explicitly define the connecting point, it sets forth guidelines that influence how local jurisdictions interpret the code. NEC Section 210.52 C1 covers wall counter spaces and states that a receptacle outlet shall be installed at each wall counter space that is 12 inches or wider. Receptacles shall be installed so that no point along the wall line is more than 24 inches, measured horizontally from a receptacle outlet in that space. NEC Section 210.52 C2 addresses island and peninsula countertops. For a peninsula, at least one receptacle outlet shall be installed at each peninsula countertop space with a long dimension of 24 inches or greater and a short dimension of 12 inches or greater. A peninsula countertop is measured from the connecting edge. The interpretation of the connecting edge is what leads to variations. Some inspectors view the wall as the connecting edge, requiring receptacles on the wall if the peninsula extends 24 inches or more from the wall. Others consider the point where the countertop meets the peninsula cabinetry as the connecting edge, allowing receptacles on the peninsula itself. To ensure compliance, carefully review local amendments and interpretations of the NEC. Engage with local electrical inspectors or building departments to understand their specific requirements for kitchen peninsula receptacle placement. Document communications and interpretations in case of future discrepancies or questions. Consider multiple receptacle options, such as installing receptacles on the wall and on the peninsula, to meet varying interpretations and provide ample convenience for the homeowner. Employ detailed drawings or sketches to illustrate the intended receptacle locations and obtain approval from the inspector before commencing work. This proactive approach can prevent costly rework and ensure adherence to local electrical codes. It's also essential to understand the general requirements for kitchen receptacles, in addition to the specific rules for peninsulas. Kitchens require at least two 20-amp small appliance branch circuits to serve receptacle outlets for appliances. These circuits must serve all receptacle outlets in the kitchen, pantry, breakfast room, dining room, or similar areas, with limited exceptions. Receptacles installed to serve countertops must be readily accessible and cannot be located more than 20 inches above the countertop. Ground fault circuit interrupter, or GFCI, protection is required for all 125-volt, 15 and 20 amp receptacles serving countertops in kitchens. This protects against electrical shock hazards in damp locations. Arc fault circuit interrupter, or RSI, protection is also required for branch circuits supplying outlets in kitchens. This protects against electrical fires caused by arcing faults in wiring. When installing receptacles, use appropriate wiring methods and materials that comply with the NEC and local codes. Common wiring methods include non-metallic sheath cable or NM cable, and electrical metallic tubing are aimed. Ensure proper grounding and bonding of all receptacles and metal enclosures to prevent electrical shock hazards. It's critical to properly size conductors and overcurrent protection devices for the circuit serving kitchen receptacles. Refer to NEC Tables 310.15. B16 for ampacities of insulated conductors and NEC Section 240.4 for overcurrent protection requirements. Typically, a 20 amp circuit requires 12 American wire gauge, or AUG, copper conductors or 10 AWG aluminum conductors. Overcurrent protection devices, such as circuit breakers or fuses, must be readily accessible and properly rated for the circuit. Label all circuits serving kitchen receptacles at the electrical panel to facilitate identification and troubleshooting. Keep in mind that kitchen islands have similar receptacle requirements to peninsulas. At least one receptacle outlet must be installed at each island countertop space with a long dimension of 24 inches or greater and a short dimension of 12 inches or greater. Receptacles on islands must be located within 12 inches of the countertop surface. GFCI protection is required for all 125 volt, 15 and 20 amp receptacles serving countertops on islands. When installing receptacles in kitchens, consider the placement of appliances and potential obstructions. Avoid locating receptacles behind large appliances, such as refrigerators or dishwashers, where they may be inaccessible. Ensure that receptacles are readily accessible and do not interfere with the use of countertop space. Consider installing additional receptacles to accommodate the use of multiple appliances simultaneously. When wiring kitchen receptacles, follow safe electrical practices to prevent electrical shock and fire hazards. Turn off the power to the circuit before working on any electrical components. Use insulated tools and wear appropriate personal protective equipment, or PPE, such as gloves and safety glasses. Double-check all connections to ensure they are tight and secure. Test the receptacles with a receptacle tester after installation to verify proper wiring and grounding. In conclusion, determining the connecting point of a kitchen peninsula involves understanding local interpretations of the NEC and consulting with the AHJ. Adhering to these guidelines and best practices ensures electrical safety and compliance in kitchen installations. Remember to prioritize safety, consult local codes, and communicate with inspectors to achieve a successful and compliant electrical installation. Moreover, specific regional amendments to the NEC could further shape the interpretation of the connecting point. Several jurisdictions adopt the NEC but introduce local modifications to cater to their specific construction practices or safety concerns. Thorough research into these local amendments is crucial before commencing any electrical work. These amendments can be found on the websites of local building departments or through consultations with electrical inspectors. For instance, a jurisdiction might have a stricter interpretation of readily accessible, which could dictate the precise placement and type of receptacles allowed on a kitchen peninsula. Additionally, the type of construction material used for the peninsula can influence receptacle placement. Some areas have specific regulations regarding wiring methods and receptacle box types for structures built with combustible versus non-combustible materials. Certain municipalities might also have energy efficiency requirements that indirectly affect receptacle placement. Energy codes might stipulate the use of specific types of low standby power receptacles or require occupancy sensors to control lighting and receptacle circuits in certain areas of the kitchen. Such requirements might impact the overall electrical design and placement of receptacles on the peninsula. It's also important to consider future kitchen renovations or appliance upgrades when deciding on receptacle placement. Providing additional receptacle capacity and strategically locating them can accommodate future electrical needs without requiring extensive rewiring. Consider the potential use of smart appliances, which might require dedicated circuits or specialized receptacles. Planning for these future requirements can enhance the functionality and value of the kitchen. Furthermore, the Americans with Disabilities Act, or ADA, guidelines can affect receptacle placement in accessible kitchens. ADA standards dictate the height and accessibility of receptacles to accommodate individuals with disabilities. Ensure compliance with ADA guidelines in accessible kitchens to provide safe and convenient access to electrical power. The presence of specific appliances, like built-in microwaves or induction cooktops, can also influence receptacle placement on the peninsula. These appliances often require dedicated circuits and receptacles, which must be located in close proximity to the appliance. Coordinating receptacle placement with appliance locations ensures a clean and functional kitchen design. Also, remember to document all electrical work, including receptacle placement and wiring methods, for future reference. Maintain detailed records of inspections, permits, and any deviations from the NEC or local codes. This documentation can be valuable during future renovations, maintenance, or property sales. When working on kitchen electrical projects, collaborate with other trades, such as carpenters, plumbers, and countertop installers, to ensure seamless integration of electrical components. Coordinating efforts with other trades minimizes conflicts and ensures a cohesive kitchen design. Communicate effectively with all stakeholders to avoid delays and ensure that the project meets everyone's expectations. Staying up to date with the latest electrical products and technologies can also enhance the functionality and safety of kitchen receptacle installations. Consider incorporating features such as USB charging ports, tamper-resistant receptacles, or surge protection devices. These technologies can improve convenience and protect sensitive electronic equipment. In high-end kitchens, consider incorporating decorative receptacles and switch plates to enhance the aesthetic appeal of the space. Select receptacles and switch plates that complement the kitchen's design and color scheme. These details can elevate the overall look and feel of the kitchen. Remember to properly train homeowners on the safe use of kitchen receptacles and electrical equipment. Provide instructions on how to avoid overloading circuits, identify potential hazards, and respond to electrical emergencies. Educating homeowners on electrical safety can prevent accidents and ensure the longevity of the electrical system. In addition, consider the use of arc fault circuit interrupters, RF size, and ground fault circuit interrupters, or GFCIs, for enhanced protection against electrical hazards in the kitchen. ASIs protect against electrical fires caused by arcing faults, while GFCIs protect against electrical shock hazards. These devices can significantly improve the safety of kitchen electrical installations. Finally, always prioritize safety when working on electrical projects. Wear appropriate personal protective equipment such as gloves, safety glasses, and insulated footwear. Follow safe work practices and never work on live electrical circuits. If unsure about any aspect of the electrical installation, consult with a qualified electrician.